calculate the mean of that event x. Then join PDF of two random variables. The previous thing we what was the joint probability PDF. Now this is joint PDF. Now the joint PDF of two random variables x and y defined in terms of the probability of the following joint events denoted with a set of intersection symbol. Joint means mix, means that both events occurs at the same time. So this is denoted by the set of intersection symbol. Both occur at the same time, means if two sets A and B, then suppose eta is common, eta lies in A set and eta lies in B set as well. So we use intersection. So in the intersection we combine the probability of the x, p of x, and x is lies between this value, and y is another set is lie in the eta in between this value. So the number, the event lies in this set and in this set as well. So then probability of this set intersection this set divided by difference of the epsilon and difference of the eta. So this is the joint probability that both random variable in both events x and y occur at the same time and both have a intersection set. So this joint PDF is used in the multiple object tracking. So in the multiple object tracking, the same measurement of the object can occur at the same time. Okay, when we are tracking multiple objects, then multiple objects can occur at the same time. Then we use the intersection of the random variable. Variable is same, means suppose that x is same, x is lie, and x belongs to set A or target A, and x also belongs to target B. It's common. Then we have to find this probability, and the integrating the joint PDF of two random variable over one of the variable yields the PDF for the random variable. So in this case, what we will do, we will find the joint probability of the one variable, which will yield the PDF of the other random variable. Means if we will integrate p of xy, this is joint, means two events are mixing together, x comma y. Then first we integrate this function with respect to eta. This is just like partial differential. You know partial differential, when we differentiate partial derivative with respect to two variables, then we assume one variable is constant. We do not differentiate that variable. We derivate it with respect to another variable. So this is same thing. First we same function. First we differentiate this with respect to eta. This will give you px of epsilon, and another way we can calculate we can integrate this thing with respect to epsilon, and in that case we can write a p y comma x, and here we write epsilon, then it will equal to p of y of eta. So using the simpler notation, PDF of x comma y differentiate with respect to integrate with respect to y equals to p of x. The resulting PDF which pertains to a single random variable. So we say that this is a marginal PDF. So I mean, this is the way to calculate the probability of multiple target. how we calculate the PDF of this whole function with respect to first suppose eta, then and keeping this constant, like suppose we assume that this is not any value, this is a collector means any other unwanted measurement, then we integrate this thing to calculate the probability of eta, that is eta is the target and this is not a target. Then and the so this way we have to say that the resulting PDF pertains to a single random variable, and in the next time we can also calculate that epsilon is the probability that it is the target. Then we just compare which has the highest probability. Okay, so we will use these type of formula and object tracking when we go ahead. So this is in this joint probability we have to find the first probability of the other set and then the other set. Then conditional probability. Okay, so you already know conditional probability, but why we use this conditional probability? So why we use the conditional probability? So frequently before observing the outcome of a random experiment, before you start any work, you already know the outcome. Means if you learn this subject, you know what is the outcome of this subject that you will apply and develop some algorithm. This is your outcome, means this is your desired wish that you will develop your algorithm, you will build a project. This is your outcome. So you already know what is your objective. Your objective is to study the subject. This is the outcome. So you have already been given an objective. So and before that you are observing. So what is the probability of study? Condition that you have already given the all contents of the book. The contents of the book already given to you. Now what is the probability that what will you study? So frequently before observing the outcome, you are given information regarding the outcome. You know the outcome. What is the outcome? Okay. How should this information be used in prediction of the outcome? How should the probabilities be adjusted to take into account this information? Means already some information is delivered to you. Now you have to find the outcome. Some information means some sample space is already given to you. Now I am asking that you have to find some probability of some variable like x. So you have all information, means conditions, means I'm asking to find this value x based on this value. So based on this value is the condition that you have data and you have to find x. So usually the information is given in the following form. You are told that outcome belongs to a given event. Means you are told, means you have already know the information. Now you are finding a certain value. that has occurred, and that event belongs to whatever you have told. Okay, means you already know the B, now you are finding the A. B is already known, and you are finding the probability of A based on knowing information of the B. So suppose that we are interested in computing the probability of the event A, and we have been told event B is already occurred. Okay, you have been told that B is already occurred, now you have to find the B. Now you have to find the probability of the A, and probability of the B has already been calculated. Probability of B is already calculated. So then conditional probability of the A given B is defined to be intersection of the two sets A and B and probability of B. Why we use intersection? Because you are finding a condition on B, then A must be intersect the B. They should have a common point. Okay, this must be intersect to the B, because you are finding the probability of A based on, and you have given already know the probability, you have already calculated the probability of the B, then it must intersect the B and divided by the P of B, where P of B is not equals to 0. So if you are told that event B has occurred, then sample space is restricted to B. So sample space is restricted to B. B is already known, and you are finding this thing. The probability within B has to be normalized. This is achieved by dividing by PV. So the probability within the B has to be normalized. This B has to be normalized, and this is achieved by dividing the P of B. The event A can now only occur if the outcome is in A intersection B. The event probability of event can only occur if if A intersect B. If A intersect B, then probability of A can occur. Hence the new probability of A is this thing. Okay, clear? So in object tracking, you will find the probability of target existence. Suppose based on that target is already existed in the previous scan. Suppose you are finding the object existent at scan number 5, conditioning that it is already been observed and detected in scan number 4. So it must intersect, means the probability that of the scan number 5 is or condition of previous scan, means the target is already existed in the previous scan. Here, for example, the Academy Awards is soon to be shown. Okay, just you study yourself. Okay, so can anyone tell that if the husband is watching the show, then what is the probability that his wife is also watching the show? Means the same show, okay, same show, same program or watched by the couple. So husband has probability 80% and the wife has probability of 60%, no 65%. If they both watch, they have 60%. both first means intersection. Means suppose H for husband and W for wife. H intersection B equals to 0.6 probability, and P of H is 0.8 and P of W is 0.65. And you have been asked for husband watching. What is the probability of you have asking for P of W condition of H. So what is the value of this probability?
75. 75.
W for wife and H for husband. And the P of H is 0.8 and P of Y, the P of W is 0.65 and P of H intersection W is 0.60. Up to now you are clear? I'm going really fast. I'm going fast or slow because everything I have written everything very small. Up to now every slide is being written separate for each topic, so that you can easily understand.
Yes, no problem.
No problem.
Yeah.
So husband probability 0.8 and wife probability 0.65, and both can watch the same program with 0.60. 0.60 divided by 0.8. Then suppose wife is a event, then probability of I given B is 0.75. Okay. And conditional probability. So what is conditional Pdf? Okay, you know conditional probability, this thing. This is the intersection of A and B and divided by P of B. What is conditional Pdf? Conditional Pdf of one random variable given another random variable is given by this thing. Okay, what is difference between conditional probability and conditional Pdf? What is the difference between conditional probability and conditional Pdf? Both equations are written in front of you. This is conditional probability and this is conditional Pdf. So what is the difference between these two? What is the difference between these two?
Conditional probability is a point value. Pdf is sum of probability value. No?
Conditional probability is kind of discrete. No?
It's very simple, as I already told you that P is the probability. Okay, means the probability when we talk about the P of something, that we are always asking for probability of existence, and when we this small p is a PDF, and when we talk about and when we put this line, it means conditional. This line means conditional. So PDF of X, condition of Y. PDF means the distribution of random variable, and this is probability of event A. This is means the probability of the event A that it occur. This is the PDF distribution. This is the distribution of the random variable. This is not a random variable, this is the event, this is the random variable. Okay, another difference is this is the event, that any event like two of the two outcome from rolling a die, that is a is a 2, a equals to 2 means event, this is the event, then the probability of the event 2 that it will occur from a die, and this is a distribution of x, any random variable. Okay, so this is main difference, otherwise the formula is same, and when we write the conditional Pdf of the distribution, then it will equals to Pdf of x comma y, and divide by p of y. And for an event, the condition on random variable, one has this one means the probability of the event condition on the distribution A, distribution x, equals to p of this one, and the condition of Pdf for the random variable like x, the distribution of x, condition of the event. The capital thing is event, and the small letter is the distribution. So when we use this thing, okay, we know this thing, probability of the event and the distribution and the Pdf of the distribution. So when we use this thing means that suppose this is any object, this is mic is any object, and suppose there are many mics in the sample space, there are many mics, then each mic is an event in the sample. This table is whole sample space, and there are many mics, suppose 3 mics, then all 3 mics is a 3 event in the whole sample space, and we want to calculate the this thing, the event, you know the event, and then its distribution means what is the you know the distribution is already given. The suppose this distribution means the position of this is already known, or the prediction, distribution or prediction or any means the position, you are predicting the position of the mic in the sample space. So you have already known, you have given a prediction of the position of this mic. Now you have been asked that you have to find the probability of this mic that it is exists at this position, in this prediction, in this position. So distribution is prediction of the state of the object state, and A is the event of the object. A is the event of the object, and X is the prediction of the object. Okay. So event, you can say the identification of the event. 2 is the identification that it is 2. It is the ID of 2. And what is the position? What is the position of the 2? It comes at the second position, like this one. Independent events. Okay, the 2 events A and B are called independent. If the intersection of 2 variables is equals to the corresponding probability of each variable, and each variable are independent. So if the probability of their joint events equals to the product of their marginal probabilities, like this, means the product of the individual probability of the A and B. So for set of point probabilities, suppose A I equals 1 to up to n, this is point probability, are independent if the joint probability of their intersection is equal to the product of the corresponding marginal event probabilities. This again we write capital P. If we write capital P, then when there is a capital P, then we are calculating the probability of the event I, and I belongs to the set of A. A is any set, and I is the ith measurement of the event A. Similarly, if PDF, then n random variables are independent if their joint PDF equals the product of their corresponding marginal densities. The small p and this x ith measurement or ith prediction of this distribution of the x. So in the conditional probability, this intersection equals to this one. So these are independent probability, independent events. These are independent events. And suppose A and B is not equals to 0. Then PB cancel equals to P of A. So if A and B are independent, then probability of A condition B equals to probability of A, and probability of B condition of A equals to probability of B. So thus in case of independence, the conditional probability of an event is not affected by the knowledge of the other event. So means if one event is occur, then this event is not dependent on another event. Okay. So another way, the two independent variable, we can write the condition probability A intersection B or P of B equals to PA. This is actually a ratio of the probability of the set A within B is the same as this ratio of the probability of the set A within the entire sample space A. Means if in this section P of B and P of B is cancelled equals to P of A, so this is the same as the ratio of the probability of the set A within the entire space. Means the probability A is within the entire space. It lies in this space. And then this is the same multiplicative rule, the same thing that we have discussed previous slide. And here A and B are independent. Total probability theorem. Suppose this is sample space and A is any path, and these are the point probability B1, B2, B3, B4. Suppose there are 4 points and this is a sample space A. Okay, then it follows that the A intersection BI is a partition of the event A. Means this is a partition of the event A. B1, B2, B3. The intersection of B and A is intersecting all these partition. Means A event is A capital, means event A is inside B1, is inside B2 and inside B3. The same is A intersection BI is the partition of event A. Then P of A equals to sum of P of A intersection BI. So assume further that P of BI is greater than 0 for all I. So this is total probability theorem, that P of BI into P of A conditional probability BI. Means what is means and how we use it in object tracking. Means for example, in it is used in estimation. Means suppose we are estimating some object like this is any object, we are estimating this object. Then this object has many distribution, many prediction, that this event, this event is occur at this prediction, at this position, at this position, or at this position. The same object is lie at this place, or this place, or this place. So we already know this thing. So this is actually bi. This is bi1, bi2, and bi3. 3 bi, and this is the partition of A. So A, it can occur this way, this way, this way, or it is intersecting. This event is intersecting in the B1, B2, and B3. Then, and this B you have already known. Then what is probability of Pi? Means we use the conditional probability of this object, this event, P of A, condition of B, P of A, condition of B, multiplying the probability of Bi. This is the weighting. This is weighting, multiplying this thing equals to probability of A, that it is here. So this is actually the probability of the A intersection B is a partition of the event A. Clear? So it is stated that for any event A, this probability can be decomposed in terms of conditional probabilities. So it can decompose in case of conditional probabilities. P of A, condition of B3, P of A, condition of B4, P of A, condition of B2, and P of A, condition of B1. So for any event A, this probability P of A can be decomposed. We have partition in 4 partition in terms of conditional probabilities. So the key to above is the mutual exclusiveness and exhaustive of the set of the event B. What is the meaning of this? That only one event is true, because this mic can be either here, either here, either here, either here. And at the current scan, the mic at the current time this same mic cannot occur the all position. In the current time, this mic can happen at only one position. Okay, it cannot occur at the same time. It cannot occur at the same time here or here or here. But in next time scan, it will move here like this one. But in the current scan, it cannot happen here and here as well. So only one event is true. Out of all Bi, only one event is true, that A lies in that B. Okay. This is last slide. You already know this Bayes formula. Then any question here? This is already we have discussed in our previous lecture. So we apply the total probability theorem in this Bayes formula, and here we are summing up. We are summing up the probability of B, and we are summing up the product of the probability of B and the conditional probability. That the event A is conditioning on B1, 2, 3, 4. So is apply the total probability theorem in the conditional probability of the Bayes theorem. So probabilities BR, PBI are called the probabilities of B event, and probabilities of BI condition A are called posterior probabilities of the event BI. So given that the event A occurred, okay, so any question? Are you sure?
Yeah.
So in the next class, I will ask some few questions from you. Okay, like what is conditional probability? What is difference between the conditional probability and the conditional PDF? What is capital P? What is small p? And what is Weiss formula? What is total probability theorem? How we use it, this total probability theorem? We use total probability theorem and the algorithm like Kalman filter. Kalman filter is suppose the estimate this object, and but this object has many estimation. That this estimation of this, the position of this object here or here or here. Then we add up all probabilities, and to show the probabilities is here like this one. So you have to, I can ask how we use total probability theorem and the algorithm of object tracking, how we use this, the Bayes theorem and object tracking, and what is conditional probability in the object tracking. Okay, so you can answer me like that in the sample space any event can occur. So whole sample space is already known to us, then we have to find the probability of any x event from the sample space, means based on the sample space. Okay, so here you can end stop the recording.